Okay, so the first section is 9.1 trig functions in right triangles. So you should be taking these notes along with me. Now this is my second recording because the first one was a little awful, and I'm sorry for that. I'm going to re-say this for you. I'll read them to you just like as if I were to read them to you in person, and then we will go through everything again, okay? Now, 9.1. First word is trigonometry. Trigonometry is the study of relationships among the angles and the sides of a right triangle. Again, it is the study of relationships among the angles and the sides of a right triangle. That's what we're going to be studying. A trig ratio compares the side lengths of a right triangle. Again, compares the side lengths of a right triangle. And a trig function, that's our last word for the first part, it has a rule which is given by a trig ratio, which is what we're going to talk about. So has a rule given by a trig ratio. So there are 6 trig ratios. First thing I would do is I would draw this triangle over here. Give you a little room so you can see it, okay? So draw a right triangle. How we know it's right? Because it has that little right square in the corner, right? Okay. Now, then we drew this little sign right here. It is like a circle or an O with a squiggly line through it, like a similar sign through it. It's called theta. And then we would label these later. So the 3 main trig functions are sine, cosine, and tangent. Now, from those 3, we're going to learn the other 3. But we first have to learn these, because if we can learn these, we can learn the other 3. These are the 3 main ones we will always come back to, always use. Sometimes we'll never use those. It just depends. Okay? So sine, cosine, and tangent are all based off of where this angle is, which is why we labeled these 3 sides of the triangle. Now, the first most important side is the hypotenuse. The hypotenuse side, and I abbreviated it, is always across from, it's the side that's diagonal to the 90-degree angle. So the hypotenuse is always the longest side, aka the side across from the 90-degree angle. And then the side across from this, opposite, we just labeled it, it's opposite. So the side across from the theta is called opposite. The side that's next to it or touches that angle is called adjacent. Okay, we need those 3 words. From there, we can make our 6 trig functions. So sine of theta, we always abbreviate these originally, and you can see them on your calculator as the first 3 letters of each word. So sine is abbreviated S-I-N. We always call it sine. You never call it sin. It's just sine. So sine of theta equals the opposite over the hypotenuse. I would literally just either write the whole word opposite or abbreviate it. Opposite divided by hypotenuse. Highlight it and know it. It's important. Cosine, or COS, cosine of theta is the adjacent divided by the hypotenuse. And then tangent, or tan, of theta is equal to the opposite over the adjacent. So those are the 3 main ones. We have to know them. We'll have to memorize them. You can't look back. There will be no note card on this later. You have to just know them. Once we know these, we can learn the next 3. They are in line in this order for a specific reason, because these guys are like inverse of each other. So the inverse of sine is cosecant. I spelled the whole word out for you. The abbreviation for cosecant is CSC, cosecant. Let's think about how you would, like the enunciations on the word, cosecant, CSC. Cosecant of theta is just the inverse, the flip of sine. So it's hypotenuse over opposite. Secant, or SEC, of theta is equal to the inverse of adjacent. I mean, the inverse of cosine, so hypotenuse over adjacent. And then cotangent is the one that makes the most sense. Cotangent is the inverse of tangent, so it's adjacent over hypotenuse. Okay, so now we're going to use all that knowledge, and we are going to look at this triangle over here. So this is the triangle they gave us. We have A, B, and C. They almost always put C in the middle when we have A, B, and C. I can't tell you why, other than we always represent C as our hypotenuse, so they always put C there. I'm not sure who decided that, but that's what they decided. Okay, and then we have 3 side lengths. We have 8 across from A, 15 across from B, and 17 across from C. We're going to use those, and the instruction says, find all 6 trig functions. So you always find the main 3 first. So sine is opposite over hypotenuse. So from here, from the theta, opposite is 8, hypotenuse is 17. So 8 over 17. Cosine is adjacent over hypotenuse. So we already have our hypotenuse. Adjacent is 15 over 17. And then tangent is opposite over adjacent. So 8 over 15. Once you have those 3, all you have to do is write the other 3. Again, keep them in the same order we learned them. Cosecant, secant, and then cotangent right next to their inverses. All you have to do, you don't even have to use the triangle. You can if you want, but there's no reason to it. Just go, okay, sine. Cosecant is opposite of sine. I always remember that, see how the S is in the middle? Sine is the middle, like sine turns into cosecant. Cosine, see how S was at the end and now it's flipped around, S is in the front and C is in the end? That's how I remember it, okay? So now flip this one, 8 over 17 turns into 17 over 8. 15 over 17 turns into 17 over 15. And then 8 over 15 turns into 15 over 8. It's that basic, okay? Another vocabulary, a reciprocal function. We basically just learned it here. They're called inverses. So cosecant, secant, and cotangent are all reciprocal functions of sine, cosine, and tangent. Okay, that's basically what we said. They're inverses of each other. It's just another way to say a reciprocal form. Another way to look at this form is to say that cosecant of theta is equal to 1 over sine, because we flipped it. Instead of being sine divided by 1, just like whole numbers are like 10 divided by 1, now it's 1 over 10. That's the inverse, right? 10 over 1, the inverse of it is 1 over 10. That's where this has come from. So cosecant of theta is 1 over sine of theta. Secant of theta is 1 over cosine of theta. And then cotangent of theta is 1 over tangent of theta. Okay? Now, we're going to do the same problem, same kind of problem, but we're only going to be given so much information. So the only information we were given is we have sine of B, it's right there, is equal to 5/8. That's all they gave us. No picture, no information other than that. So sine of B is 5/8. That means we have a triangle. We can call it ABC if we want. It just has to have B in it. Okay? So I erase it. So I made a triangle with A, B, and C. And I put theta in B because that's where my sine of B is. Then we go, okay, 5/8. Sine is opposite over hypotenuse. So opposite of B is 5. 8 is my hypotenuse, 8. So we do not know this third side of the triangle. We're missing this third side length. Okay, well, it's right up here because I already wrote it and highlighted it. Can't hide that one. Now, as a reminder, anytime you have 2 sides, this is back to like middle school, and you want to find the third side, you use the Pythagorean theorem. And if you have A, B, and C, look, it's so much easier because that uses A, B, and C. So use this formula and plug in the number you have. Little b is 5, little c is 8, and we don't know what little a is. We want to find it. So look, it's right here. Little a squared, because we don't know what it is, plus 5 squared equals 8 squared. So we square them. So we have a squared plus 25 equals 64. Well, let's solve. Subtract 25 from both sides. You get 39. A squared equals 39. Got to take the square root of both sides. I get a equals the square root of 39. I type that in. It does not make a pretty number. If it does not make a whole number, then you leave it alone. Or a solid decimal. I'm talking like 0.5. ends, it is non-repeating, or it does not terminate. If it goes on forever like pi or anything else, it's not pretty in any way, you just write it like that and call it a day. So square root 39. So I'm gonna take that and I'm gonna write right here, square root 39. So I have all three of my sides on my triangle. Now I can find all 6 trig functions. So let's start with the basics. Oh, we already know what sine of b is. Now I have to find the rest. Cosine of b. So cosine of b is adjacent, so square root of 39 over 8. That one's pretty easy. Tangent of b is the opposite, which is 5 over square root of 39. Now that's all nice and all, but one rule we have to remember is that the radicals can never be on the bottom, right? It's not allowed to be in the denominator. No variables in the denominator, no radicals in the bottom in the denominator, right? Those are our 2 main rules. So to do that, we multiply the top and the bottom by the square root of 39. On the top, it just turns into 5 times the square root of 39, just is left alone. If you type this into your calculator, square root of 39 times square root of 39, you just get 39. That's because this is 2 things. That's really a square root of 39 squared, because you have 2 39s. What happens when you have squared and square root? They cancel out. All you're left with is 39. It's always just the number without the square root. So that one's simplified. So now we have tan of b. So now when we find our 3 other trig functions, look at the original before it was changed. So when we look at the tan one, we're going to look at this original, just in case it makes our lives easier. So cosecant, look at this one. Flip it. 8/5. Super easy. Done. Now the cosine one, when we flip this one, it's going to give us a radical in the bottom, and we don't want that. So again, multiply the top and the bottom by the square root of 39. Those cancel out to just be 39, and that turns into 8 square root of 39. Now, if you could, you can't in this case, but if you could take 8 over 39 and simplify just those whole numbers, you should do it. We can't because 8 and 39 have nothing in common, but if you could, you should. And then cotangent, look at the original, 5 over square root of 39. That flips to be square root of 39 over 5. Since that has no radicals in the bottom, that's pretty. It is done. These are like the first couple sections of your homework, okay? I'm going to flip. Okay, make sure I could see, you could see. Okay. Now, let's talk about special triangles. Now, you were supposed to learn this in geometry. Now, whether or not you did, whether you're a sophomore and you were never taken geometry or you never remembered or paid attention, different story. So we're going to pay attention. All of this is super important. The stuff we're going to learn about the trig functions is also things you have to memorize. So let's look at the basics first. A 30, 60, 90 triangle looks like this. It's still a right triangle. It has a 60-degree angle, a 30-degree angle, and a 90-degree angle. The sides are marked in a specific way. Across from the 30 degrees is an x. Across from the 60 degrees is x times the square root of 3. And across from 90 degrees is 2 times x. Those side lengths always stay that way. So that way, if there was a number 2 here for x, you can find all the other side lengths without any kind of help. Or if you had a 5, or nah, 5 doesn't work, but like any other number, if you had 10 here, you could figure it out. You could figure, okay, well, if that's 10, well, then this is 5. If that's 5, then this is 5 square root of 3. So you can use this to figure out the other side lengths if it's one, if it is this specific special triangle. Okay? So that's important to know. Okay? Just something to think about. And then we're going to look at the 45, 45 real quick. Now, the 45, 45, 90 triangle, since the angles are the same, the sides are the same, so they're x and x. The side across from 90 is x squared root of 2. How to remember which square root goes with which? The 30, 60, 90 has 3 different angles, has a square root of 3 on it. The 45, 45, 90 only has 2 different kinds of degrees. It has a square root of 2 in it. That's how I remember it. It's up to you. How do you remember it? But that's how I do. Now, in these, let's talk about 30 degrees first. You could type this into your calculator. You would know your answer. You can type this in your calculator as long as, let me grab mine, that you know that you're in the right mode. Now, we can use our calculators in some instances, coming up. As long as you are aware how to make sure your calculator is in the right format. So if I turn my calculator on, we want to look at, to make sure you're in the right mode, because we're talking about degrees right now, you push the mode button. Oh, this one, I must have changed it. So you're going to go down, and right now mine is highlighting the word radian. I want it to highlight the word degrees, so I'm going to just click on degrees. And then if I move up, do you see now how it's highlighting the word degrees? It has to highlight the word degrees for it to work. So push second quit. Now it would work. If it was in radians and I tried to work using degrees and typing them in, it would not work. So you have to check your calculator before, especially since later on we'll be moving between one and the other a lot. So you'll have to know which one you need, okay? Ooh. Okay, so now, sine of 30 degrees, the answer is 1/2. You could type it into your calculator and see it. 0.5, 1/2, see? Okay, something you need to memorize. Cosine at 30 degrees is the square root of 3/2. If you type that in your calculator, you're just going to get an ugly decimal. This is the correct way to write it, which is why the calculator is not always 100% helpful. And then tangent of 30 degrees is the square root of 3/3. We always keep our answers in fraction form. And these fractions are fine, right? Because the radicals are on the top of the fraction. So it's 100% okay. Okay. Now, if you did not know this, or you didn't pick up on it on the front page when we were looking at opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, sine and cosine, when you do sine divided by cosine, you actually get tangent. So if you did 1/2 divided by this guy, that's where that comes from. That's how that is made, actually. If you don't believe me, try the math. Do 1/2 divided by that and multiply by the inverse. You'll get the same answer, okay? It will work for all of them, okay? All of these important you need to know and memorize for later, okay? Next, sine of 60 degrees is square root of 3/2. You don't even have to memorize it, because the cool thing about sine and cosine is whatever cosine is at 30, that's what sine is at 60. Whenever sine is at 30, that's what cosine is at 60. So they kind of like switch spots. They like swap each other's numbers. So sine at 60 is square root of 3/2. Cosine at 60 is 1/2. Tangent is sine divided by cosine. So it's the square root of 3, because you switch the order. And then the last one. Sorry, it's too early for this. Sine of 45 degrees is the square root of 2/2. This is the special triangle. Cosine of 45 is also square root of 2/2. And then tangent, anything divided by itself, is 1. So these answers for these specific degrees for these 3 basic functions are very important to know. And they will ask you for them, or they'll ask you to find some answers using them, okay? Now we're going to start kind of using them right here. Now, you're going to be given a triangle just like this. This is the picture it gave you. It gave you a degree, a side, and a variable. Obviously, it says find the value of x or y or whatever variable it gives you. Sometimes it gives you x and y, so you have to find one and then the other, so do one at a time. Okay? Now, when you're here, you go, okay, 30 is here. What sides do you have? You can always just label them. So that's my opposite side, this is my adjacent side, that's my hypotenuse. So I have something for A and something for H. So which trig function says A and H out of the 3 main ones? I know that the inverses also have them, but I would like to stick with the 3 ones. So which one of them has A and H? Well, that's cosine. So we're going to make this equation right here. Cosine of 30 degrees, because that's the degrees we have, equals adjacent over hypotenuse. So I made that equation. So then we go, how do I get x by itself? It's a basic solving problem. You just have degrees in there. Just ignore it for a second and go, how to get x by itself? Well, x divided by 8, so times 8 on both sides. So now I have 8 times cosine of 30 equals x. Well then, you take your fancy calculator and type it in. 8 times cosine at 30 degrees. 6.9. It said 1 decimal place. Look, x equals 6.9. Ta-da. Here's a second one. Almost the same. figure out which one you would do. It's a little ugly on the drawing, but 45 is here. X is 10's over there, opposite from it. X is the hypotenuse. It's hard to see, but look at where the 90 is. So O and H is sine. Sine of 45 equals 10 over X. When X is on the bottom, I always turn both sides into fractions. So you have sine of 45 over 1 and 10 over X. And then when you have this, you can cross multiply. That way you can see that, oh, this has to change. So that way, in the end, what you're really doing is you're going to have X equals 10 divided by sine of 45. Again, type that in. 10 divided by, I would put in parentheses, sine of 45. See how I double parenthesed it because I put parentheses in front of the sign? 14.14. So since one decimal place, 14.1. They are the same. Okay? There's more in the book to practice too if you would like. Okay? Now we're going to do the same exact thing, but now all we've been finding so far are sides. Now let's find an angle. This is when our inverses come in. And if you look at the calculator, you see how we have sine, cosine, and tangent? What do you see above them? How it says sine to the -1, cosine to the -1, tangent to the -1. Those are the inverses. Well, since those are blue, remember we're gonna have to use our second button to get them. So let's show you how it works. So you look and see what you have. So you got, okay, theta's here. 6 is over here. That's my opposite. 10's here, that's my hypotenuse. So I have O and H, that's sine. So sine of some angle, because we don't know what it is, equals 6/10. So if you have everything but an angle, you go, I want to switch these, because when you want to solve anything in math, right, that thing has to be by itself. But we can't just move the theta because it's like super glued to the sine. So to get rid of it, we have to like do the inverse. You have to make sure I'm doing something purposefully. You can't just divide because it's sine of something. It's of the 30 degrees or of the 50 degrees or whatever it is. So when it is attached to a trig function, you have to do the inverse to get rid of it. So when you switch these, you have to do the inverse of whatever trig function you have. And when I type that, and then you can just type it in. So I would just push second sine, and then I would type that in, 6 over 10. And then you always do one decimal place. And then since it's theta, it means degrees, you have to put degrees. So angle N equals, because that's what it originally said, angle N up there, 36 point, rounding one decimal place, 9 degrees. Okay, here's another one. Try this one, look at this one. So here's the image. We have, it says, it actually put an X, it looks like an F in the camera. That's an X degree, so we're trying to figure out what X is. It says 18's over here, that's right next to it, that's an A. That's across from it, that's an O. Which trig function uses O and A? It's tangent. Tangent of X equals 27 over 18. Just switch their spots, don't switch the fraction. Do the inverse of tangent. See, type that in. See if you get the same answer as I do. Okay, that is all that is in 9.1. You have 2 days worth of homework. I am going to scan the pictures of the book just to let you know so you can check your answers. You can also let me know if you need any help. I think, in my opinion, the hardest part is probably memorizing them, so really none of the homework, but practice these, show your work. Don't forget that you will need to have these notes, if not just to show me, but also because when we come back, we will finish this chapter and we're not using note cards at all because you have to have all of this memorized. Okay, so it is super, super, super important. Okay.